Hi, Doc Revis here with Watch Me Work It. Combustion analysis calculations of a simple hydrocarbon, CH. Here's the problem. A hydrocarbon fuel is fully combusted with 18.214 gram of oxygen to yield 23.18 gram of carbon dioxide and 4.729 grams of water. Find the empirical formula of the hydrocarbon. Problem number 2, what is the empirical molar mass? And number 3, how many repeat units are present in the compound based on a molar mass of about 80 grams per mole. So in this case, we have 3 different segments of one problem, a combustion analysis. Because we're looking for the empirical formula in the first one, we know we need moles. To do empirical formula, we think moles. That's what we think about. We look at the problem, we don't see moles, we see grams, grams, grams. All right, so since we don't see moles, we know that we'll have to do a conversion. So we need moles of C and moles of H. We look at the problem, we don't see grams of C or H. Now that we see moles of C or H, but we do see carbon dioxide, which is a source of carbon, and we see water, which is a source of hydrogen. So we'll do an indirect calculation to get to carbon and hydrogen. Let's do it. So we write our given. Let's start with carbon. We write a given of 23.118 grams of carbon dioxide, CO2, dimensional analysis times bar, grams of CO2 on the bottom, and that will take us to moles of CO2 on the top. But we're not interested in moles of CO2, we need moles of carbon. So we would do an inner conversion here where we would take moles on the bottom, math step, CO2, and on the top, we will put moles of carbon. And that will allow us to have an inner conversion, and then we would have moles of carbon as our result. So let's go back then and put in our values. We have grams of CO2. The molar mass of CO2 is 44.00 to 1. Here, we calculate that from the periodic table of carbon, plus 2 times O, so it's 1 times C and 2 times O to get the molar mass of 44. Here we now have a molar-mole ratio of moles of carbon dioxide to moles of carbon. For every 1 mole of carbon dioxide, we see that we have 1 mole of carbon. So we take these values and we push them through our calculator. For the moles of carbon, we have 0.5252 moles, and that's moles of carbon. Now, let's get the moles of hydrogen. We'll do this also by indirect method of using water as our source of hydrogen. So water, 4.729 gram of H2O, water, times bar, dimensional analysis, and we'll put gram water on the bottom, and we'll put mole water on the top. Then we will convert these moles of water on the bottom to moles of H on the top by doing the math steps and checking the ratios and the relationships. So gram to mole, for every 1 mole of water, we have 18 grams per mole. That's because we have 2 times H plus 1 times oxygen, molar mass from the periodic table, and we get that value. When we look at the mole-to-mole ratio, we have, for every 1 mole of water, we have 2 moles of hydrogen. We simply read it from H2O. Okay, and so if we punch this number through, we'll get 0.2627 mole, and that's our hydrogen source. And so now, because we're looking for empirical formula, we will now take the smallest number of moles of each of these and divide it through all the other moles. The smallest here is hydrogen. And so we would divide this through 26, 27. We're looking for ratio of moles because ratio of moles is what gives us the empirical formula. If we do the math, this comes out to 2. This comes out to 1. And therefore, our empirical formula is C1H2 or CH2 as our final empirical formula. The next question asks, what is the empirical molar mass? Well, we could do it right here. We have 1 times carbon and 2 times H. And these are just rounding off numbers. Times 12, and this is 1.00. So this is 12, and this will be 2. So our empirical molar mass is 14.00 gram per mole. That's our empirical molar mass. All right. Next one, number 3, asks how many repeat units? Well, to find repeat units, we have to know what the molecular mass is, and it's 80 gram per mole. And so our repeat units would be equal to the molecular mass, which was given to us, found by some experiment, 80 gram per mole, divided by the smallest whole number unit called empirical formula. And so we have the empirical formula, molar mass, in gram per mole as well. And this comes out to be unitless at 5.7. Well, we don't do 5.7 because we're talking repeat units. It's always a small whole number. Well, it actually could be a large whole number, but in this case, it's a small whole number. So repeat units would be 6 repeat units. So since I have 6 repeat units, the next thing I would do is multiply 6 times this. And if I multiply this times 6, then I will have C6H12 as my molecular formula. So there you have it, combustion analysis of carbon and hydrogen in a hydrocarbon fuel. It's something you should observe. You notice here, I did not use this, did not need it, because it's in excess. Plus, the relationship we're looking for was carbon, which is in CO2, and hydrogen, which is in water. So oftentimes in these problems, you have more information than you need. In this case, knowing the amount of oxygen did not help us to find the solution. All right,